All right, so we've got a couple of exercises from section 1 of chapter 5 that people had some questions about. Hopefully some of these have been answered in the last 2 weeks. Sorry, it's been a little late making these things. Wait until I'm healthy and had time, right? But here it is. I think some people still might have a few of these questions, so I think this could be helpful. So it says, consider this equation, 2x minus 7y equals 5. So let's consider that first. We need numbers x and y that when I plug them in make this equal 5. And there are infinitely many solutions to that. So when it says solve the equation, it doesn't mean that it wants you to find a number for x and a number for y. There are lots of possible answers for that. It says solve the equation for x in terms of y. So solving for x in terms of y means x equals a bunch of junk with y in it. So right now, you could say this is solved for 5 in terms of x and y, because 5 is on its own and it equals the x and y stuff. What we want is to rearrange this without changing the problem, right? Use our properties of equality to rearrange this equation so that x is completely on its own, not 2x, but just 1x. And everything else is on the other side, right? So that's what we're doing here. The other part of this question is saying solve it for y in terms of x. And of course, that's going to mean get y on its own, solve for y, right, in terms of the other variable. So this is going to be where we get y on its own, not negative 7y, but 1y. We rearrange this using our properties of equality so that y is on its own, and over here, the only variable is x. So let's solve part A and part B. So for part A, I'm going to write down the original question, or the original equation, I should say. And we want to get x on its own, right? So to do that, we have some properties of equality. We can add anything we want to both sides. We can subtract anything we want from both sides. We can multiply by whatever we want to every term, although we probably don't want to times it by 0 because that would make this go away, that go away, and that go away, and we get 0 equals 0, which is true but not helpful. And we also can divide by whatever we want to every term, as long as we don't divide by 0, because when you divide by 0, your numbers become meaningless, right? Anything divided by 0 could equal anything. So in order to get this x on its own, I'm going to add or subtract to turn things to 0. I want to get this to be 0. And I'm going to divide to get rid of that 2 there. You can do it in any order you want. But I think what I'll do is I'll add 7y to both sides. Again, adding or subtracting is the only way to make something become 0. Because if you times to make it 0, then you have to do it to everything, and everything becomes 0. And of course, you can't divide something to make it 0. No matter how you divide up a pizza, you'll never get a slice that's equal to 0, right? So the only way to make this a 0, to make it go away, so I can get 2x on its own, is to either add or subtract. I'm going to add 7y to this, because negative 7y plus 7y is, of course, 0. In order to do that, I have to do it to both sides, though. So what I end up with is 2x plus nothing. That's why I did it, so I just get 2x. And then over here, these are not like terms, but I can go ahead and write them as separate terms. Now, I don't want to turn this into a 0, because 1, if I did that, my x is gone. And 2, I'd have to subtract 2x from both sides, and now I've got x on the right side, and I'm working really hard to get x on its own on the left. So I don't want to add or subtract. I'm not trying to make something 0 like I did here. Instead, I'm going to multiply or divide. In this case, I will divide by 2. Not 2x. I don't put an x down here. If I put an x down here, 2x divided by 2x is 1, right? It gets rid of that x completely. And then I'd have to divide everything over here by 2x, which is kind of messy. But instead, if I divide everything by 2 and leave the x, I get 2 divided by 2, which is 1. 1 times x is just 1x. That's why I did it, right? I wanted 1x on its own, right? X in terms of the other variable. And over here, since everything's being divided by 2, they have common denominators. And I can write it like this if I want. Either this all over 2 or everything divided by 2 individually is totally fine. But there it is. Here's x in terms of the other variable. And while this isn't what x equals, like a number that we're used to, it is its relationship to y. If you told me y, I could very quickly plug in a number for y and get x, right? So getting x in terms of the other variables is a very useful technique that we're going to be using a lot later on. So it's good to understand this. And the good news is you're going to do the same thing every time. You're going to make all the stuff that isn't x go to the other side. And the way to do that is to add or subtract to make it 0. Then you're going to get x on its own. If it's 2 x's, you'll divide by 2. If it's 5 x's, you'll divide by 5. If it's a half of an x, you'll times by 2, and you'll see that later. So we add or subtract to make things 0, and then we multiply or divide to get x on its own. That's kind of the same thing every time. I'm going to put down on a piece of paper, and we're going to solve this again. But this time, we're going to take the equation, and we're going to solve it for y in terms of x. So here's our original equation again, 2x minus 7y equals 5. And this time I'm trying to get y on its own. That's what this means, right? So I want to make this 0 because it's not a term of y. So I'm going to get rid of that. So I'm going to either add or subtract this. And then after I do that, I'm going to have to divide by -7 so that the -7's divide out and I get y. You can do this in any order you want, but I usually add and subtract first. So I'm going to subtract 2x this time. And of course, you have to do that to both sides so that you don't change the problem. That's a addition subtraction property of equality. When I do this, anything minus itself is 0. And that's why I did it. Because now I have 0 minus 7y, which is just -7y. So now I have all my terms of y on one side and everything else on the other. So now I want this to just be y equals, right? I want y in terms of the other variable. So I don't want to divide by y, because that'll get rid of my y, right? Anything divided by itself is 1. Instead, I'll divide by just -7. And when you multiply or divide, you have to do it to every term. So -7 divided by -7, of course, becomes 1. Anything divided by itself is 1. And 1 times y is y. And that's why I did it, because I wanted just one y. When I divide everything by -7, since they have common denominators, I can write it like this. Totally fine. Or you could write it like this individually. Some people don't like having a negative in the bottom. And so what you could do is, just like we divided these by -7 individually, right? This is, another way to think of it is we're dividing both of these by -1 and we're dividing them both by 7, right? So if I divide them both by -1, I get 5 divided by -1, which is -5. I get -2x divided by -1, which is +2x. And of course, I still need to divide them by 7. So either this or this are acceptable. They are equivalent. This is just where I divided both by the negative, this is where I divided both by that negative, right? And now it's gone on the bottom because I already did it. Here is where I haven't divided by that negative to both. So you can either divide the negative to both because it works out nicely, or you can just leave it. It's up to you. Anyway, that's y in terms of x because the only variable over here is x. And there's x in terms of y. So we're just rearranging this top equation right here in a different way. You might notice how they're related, right? To get y on its own, we had to subtract that over and divide by -7. A lot of you guys forget to divide by that -7. You put a +7 down there. It's probably because the answer key had this and you didn't know how they got that negative there. And again, to get the x here, let me zoom out so you can see it. Because eventually you should want to kind of do this in your head. Get x on its own, we're going to have to add the 7y and divide by 2. So adding 7y and dividing by 2 gets you this. All right, so let's look at 512. It says find 3 ordered pairs that satisfy this equation. So earlier I mentioned how if we have 2 variables, there are infinite solutions. There are infinite pairs of numbers that make this equation true. It wants us to find 3 of them. And what's annoying is that this is in alphabetical order, right? P then Q. And this is not. It's Q then P. So we're definitely going to screw this up if we're not careful. So I'm going to write P and Q over the top so I remember. And I'm looking for 3 different answers. Well, think about what this means. This means I have a multiple of 5, and I'm taking away a multiple of 4, and I'll get 1. So in other words, plug in a number, right? You plug in 1, 2, 3, 4, 5. You'll get a multiple of 5 out of this. Plug in 2, you get 10. 3 gets 15. 4 gets 20, right? And here I'll get a multiple of 4 when I plug in a number. Plug in 1, you get 4. 2 gets 8. 3 gets 12. 4 gets 16, right? So I want a multiple of 5 That is 1 away from a multiple of 4, right? The difference between them will be 1. Well, let's think of some multiples of 5 and some multiples of 4 that are 1 apart. Well, how about 5 and 4, right? 5 minus 4 is 1. So how can I make that a 5? Well, if Q is 1, then 1 times 5 gets us 5. And how can I make this a 4 so that when I minus 4, I get 1? Well, if P is 1, then this becomes minus 4, doesn't it? So a solution to this problem is 1 and 1, where Q and P are both 1. Again, I'll show what that is. If Q is 1, we get 5 times 1, which is 5. And if P is 1, we get negative 4 times 1, which is 4. And yes, that does equal 1. So we found a pair of numbers that work. Now let's find another multiple of 5 and a multiple of 4 that are separated by 1. Probably going to be a little bit bigger than 5 and 4. Well, the next multiple of 5 is if I were to plug in 2, right? I get 10. And the closest I can get is to make that an 8. Well, they're 2 apart, not 1 apart, so probably not that. What if I made this 15? Well, the closest multiple 4 I can think of is 12. 15 and 12 are separated by 3, so that's no-go. What if I plugged in a 4 here? This would be 20. Well, 20 and 19 would be separated by 1, but I can't make that 19 without using a fraction, right? I'd need 19 over 4 there. 4 times 5 gets us 20. Doesn't work. What if I did a multiple of 5 at like 30, right? Or let's do 25. Let's do 25. I forgot that one. So 5 times 5 gets us 25. If this were 24, I'd get 1, right? Well, I can make that 24. All I need is a 6. So if Q is 5, that becomes 25. 5 times 5 is 25. And here, if Q is 6, then I get 24. And that does give us 1, doesn't it? So P would have to be 6. I think I called it Q earlier. And Q would have to be 5. That works. That gets us 1 when we put those together. Now, it's kind of annoying to find answers like this, which is why I want to point out this. There's a pattern here. Because this is a linear equation, it has no squares, it has at most 1 variable per term, the difference between answers will always be the same. So what I mean by that is that from here to here, we have something called delta P. And what that is the change. That's what delta means. The change in the P values. Well, hopefully you can see that the change is plus 5. So delta P is plus 5. Over here, we have delta Q, the change in the Q values. And hopefully you can see that's plus 4. So in other words, whenever delta P is 5, delta Q will be 4. So that if I change from 6 to 11, if I make P 11, that's a delta P of 5, right, going from 6 to 11, then that means Q will go up by 4, making our other solution 11, 9. Now let's check that. Does 11, 9 work? Well, we get 55 minus, I goofed them, didn't I? Because P is 11. See, I knew I'd do that. P is 11. So I get 44 here, because 4 times 11 is 44. And I get 45 here. 45 minus 11 is 1. So this does work. So we could actually find a lot more than 3 answers. There will be infinite, right? But we can find a lot really quickly by using this delta P and delta Q method. Now, I do want to point out that if we had found these two first, we would have thought that delta P was plus 10, right? To get from 1 to 11, you add 10. And we would have thought that delta Q was plus 8, because to get from 1 to 9, you add 8. I want to point out that if delta P is 5 and delta Q is 4, that is the same relationship between delta Q and delta P as when we thought of it as 10 and 8. Right? 8 for delta Q and 10 for delta P. They are the same relationship. 4 and 5 has the same relationship as 8 and 10. Delta Q and delta P are consistent in their relationship. So sometimes you might find 8 and 10, but there's a simpler way to think of it. It's 4 and 5. Another equivalent fraction would be 16 and 20. And of course, 8 over 10 is the same thing as 4 over 5, because I can rewrite it as 4 times 2 over 5 times 2, and the 2's divide out to 1's, and of course that is 4/5. Notice I didn't change anything, I just factored it. So this is an important idea here. If you find one, or you find two of them, you can get delta P and delta Q, and use that to find more, right? However, if you're clever, notice that delta P and delta Q are kind of given to us. This right here is sort of our delta Q, right? It's -4, but we got +4. And this right here was our delta P plus 5. So notice that this is delta P, even though it's the coefficient of Q, the number that goes with it, right? And notice that this is delta Q, the coefficient of P. So it's a little backwards. Notice that one of them we had to change the sign as well. But if you see this, and we'll prove this later that this is always true. If you see this, this can help you right away. As soon as you find one answer, you can get delta P and delta Q and find all the rest. Always check your work to make sure you didn't goof this up though, right? Even I had these switched at one point. So we're gonna apply that logic here. So here's the last one you guys had questions about. It said, here's an equation. It's kind of gross looking. It said one solution for x and y, because it's alphabetical, is 1.2 if we plug it in here, and 1.1 if we plug it in there. Apparently when you do that and multiply them up and subtract them, you get -1.9. It says, how can we quickly find 3 more solutions? So we want 3 more solutions without writing anything. So without doing any like calculations. Well, as we said earlier, instead of P and Q, this is going to be our delta Y. And this is sort of going to be our delta X, right? It's going to be the opposite of delta X because we have to change one of the signs. So if we know that one of our answers is 1.211, we can quickly apply this to find more answers without having to do any work to figure out a multiple of 3 and a multiple of 5 that are separated by -1.9, right? That sounds kind of gross. So here's our Y value. Our delta Y should be going up by 3, and if that's the case, our delta X should be going up by 5. And remember, one of these had to have a sign changed. I chose to change that one. So apparently, if we follow this rule, 6.2 and 4.1 should work, and we should check that. So 3 times 6.2 is 18.6, and 4.1 times 5, I already took care of the negative sign, is 20.5. Does that equal -1.9? Well, 18 minus 20 is -2, and 0.6 minus 0.5 is +0.1. Yep, that's -1.9. So we're definitely on the right track here, so now we can kind of trust this. So to get another answer, I can add 5 and 3. 5 to the x, because that's our delta x, and 3 to the y, because that's our delta y. So apparently 11.2 and 7.1 will work. And to get our final third answer, because they gave that one to us, we can apply the same logic by adding 5 to this, 16.2, and we can get 10.1. And because this is a linear equation, one variable per term, no squares or anything crazy, right? We know that this change between our x's and our y's will always be the same. This one goes up by 3, that one goes up by 5 relationship. Or you can think of it as 6 and 10, or 9 and 15, right? Will always be the same. So understanding that property allows us to find answers really fast. Cool. All right, so that's 515. I'll do 5-2 next.